An engine develops 300 horsepower at 92% power. What horsepower would be developed at 70% power? So this is a problem that can be a proportion or comparison of two ratios. So let's look at this. What we have here is we have an engine and it develops horsepower. So when an engine when they say it has horsepower, what they're talking about is it has power at the shaft right here. I've got a little drawing of a V6 engine. The V is because the shape of the engine cylinders are in a V, but the power is developed at the shaft. So that's what we're talking about, an engine having horsepower. So what it's saying is that at 92% of its maximum power, it's developing 300 horsepower. And we want to know how much it will develop at 70%. So this is a directly proportional relationship, meaning that if I compare the horsepower to the throttle setting, they'll be directly proportional. So in this case, we're going to compare 300 horsepower to our unknown horsepower. This is one ratio. When I set two ratios equal to each other, that is a proportion. So if they're directly proportional, meaning if one increases, the other will increase. So in this case, we have at 100% horsepower, this engine will develop 326 horsepower. If I decrease the percentage of the throttle, then I'm going to decrease my horsepower. So if one goes down, the other goes down. If one goes up, the other goes up. That's directly proportional. And in directly proportional problems, we're going to set the two values that are related. If they're in the numerator, they'll both be in the numerator. If they're in the denominator, they'll both be in the denominator. So here the 300 goes with the 92%. So, and then the unknown value goes with the 70%. So these two are related. This is unlike our gear and speed ratio, which we've talked about. So the gear and speed ratio are inversely proportional. So we set our numerator with the denominator, and this one's denominator with this numerator here. So in this case, if one goes up, the other goes down. So in this example, if we have our driven gear, if it's getting larger, or the more teeth, or the diameter is getting larger, then the speed of that gear is going to go down, because every time the drive gear turns one rotation, the driven gear would not have rotated an entire rotation. Therefore, the RPM would go down. That's the difference between a directly proportional and inversely proportional relationship. Okay, so once that's set up, all you have to do is just solve this algebraic problem, and you're just going to cross multiply. So you get 300 times 70 equals 92x, and then divide by 92, divide by 92, and your answer is going to come out to be 228.3 horsepower. So there's other ways to solve this problem. You can solve it in a different manner. You can figure out what is 100% horsepower. So some people might want to go that route. So we do the whole times the rate equals the part. So in this case, we don't know the whole power. That would be 100% power. That's what we would need to find first. We do know the rate in this example is 92. So I'm going to convert that percentage into a decimal, make it 0.92. What I'm looking for is the whole. I'm just going to use an X for that and get rid of the multiplication sign. And the part is 300. So in this case, I need to solve for X. Do 90 divide by 0.92, divide by 0.92. So 100% horsepower, or 100% throttle, is going to be equal to 326 horsepower. So knowing maximum horsepower, I can just multiply that by 70%. So 326 times 0.7 is going to be the exact same answer, 228.3 horsepower.